Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In this chapter, we are going to discuss ICSE Class 10 Maths Chapter 18, Tangents and Intersecting Chords, Exercise 18C. In our previous sessions, we have discussed many theorems from this chapter. Hope you all remember those theorems. Today, we will be revising those theorems by doing the problems from this exercise. Hope you all are ready. Let's start. Here we have the first problem, question 1 of exercise 18C. Prove that of any two chords of a circle, the greater chord is nearer to the center. Let us consider a circle with center O. Now, I am taking two chords. This is my bigger chord and this is my smaller chord. Okay. I'll name this as AB and this as CD. Now, when I draw perpendiculars from the center, we know that the perpendiculars bisects the chord. So, OP is a perpendicular that is drawn from the center to chord AB, which is the greater chord. And similarly, I'll be drawing another perpendicular OQ from the center to the smaller chord CD. Okay, this angle is 90 degree. What we have to prove? To prove the greater chord is nearer to the center, that is this distance. This is the distance of the chord from the center, perpendicular distance. We have to show that OP is less than OQ. To prove OP less than OQ. Okay. Here we are having AB greater than CD. What is the reason? AB is the bigger chord that we have taken and CD is the smaller chord. We have AB greater than CD. Also, we have this OP bisects AB and this OQ bisects CD, which means we can write AB is equal to 2 times AP. Similarly, CD is equal to 2 times CQ. What is the reason? Bisect means divides into 2 equal half. That is, AP will be equal to PB, which means AP plus AP we can write. AB is equal to AP plus AP, and that is 2AP. Okay, so we'll rewrite this. AB is 2 times AP, which is greater than CD. CD is 2 times CQ. CQ. Cancelling 2 and 2, we have AP greater than CQ. AP greater than CQ. Where do we have AP? This is AP and this is CQ. Now what I am doing is, from this point A, I will draw a line to center O. Similarly, from C, I will draw another line to center O. Okay. So, we are getting two triangles. Now, here we have AP and this is CQ. Which is greater? We have AP greater than CQ. Therefore, angle that is opposite to greater side will be greater. Here, angle opposite to AP. Opposite to AP, we have AOP. Angle AOP. Angle AOP will be greater than, here opposite to CQ, we have COQ. Angle COQ. Angle COQ. AOP greater than angle COQ. What is the reason? Angle opposite to greater side will be greater. Angle opposite to greater side will be greater. So, we will be getting this angle and this angle. Now, what I am doing is, I am putting this angle AOP as some X and this angle COQ as Y. Let angle AOP is equal to some X and COQ is equal to some Y. Okay. Now, consider triangle APO. In this triangle, one angle we know, that is APO is 90 degree and AOP we have taken as X. Here, what is PAO then? We have angle APO plus angle PAO plus angle AOP is equal to 180 degrees. What is the reason? Sum of interior angles of a triangle is 180 degrees. Okay. Now put the values APO. APO is 90 degree plus PAO. PAO we have to find angle PAO plus AOP. AOP we have taken as X. X is equal to 180 degree. Okay. That is angle PAO will be equal to 180 degree. Taking this 90 degree to the opposite side, minus 90 degree. X to the opposite side, minus X, which is equal to 180 degree minus 90 degree is 90 degree. 90 degree minus X. Okay. 90 degree minus X. PAO is 90 degree minus X. Now when you consider the other triangle, COQ. Consider triangle CQO. CQO. When you do the same procedures, you will be getting angle. So when you take triangle CQO, will be having angle OCQ plus angle COQ plus CQO is equal to 180 degrees. Put the values OCQ. OCQ we have to find angle OCQ plus COQ. COQ is taken as Y and CQO is 90 degree is equal to 180 degree. Then what is OCQ? OCQ or QCO is equal to 180 degree minus 90 degree minus Y, which is 90 degree minus Y. OCQ is equal to 90 degree minus Y. We have AOP greater than COQ. Yes, AOP is greater than COQ, which means X is greater than Y. Okay, if X is greater than Y, and what I am doing is multiplying both sides with the negative sign or negative 1, I will be getting X by, what will be the inequality? Inequality will reverse. That is minus X will be less than minus Y. We have studied in the chapter inequalities, linear inequalities, that is when you multiply or divide with a negative number, the inequality reverses. We will be getting minus X less than minus Y. Now both sides I am adding 90. That is 90 minus X is less than 90 minus Y. What is 90 minus X? 90 minus X is angle PAO. Angle PAO is less than 90 minus Y. 90 minus Y is OCQ, or you can write it as QCO. Okay, PAO less than QCO. PAO is this angle and QCO is this angle. Okay, opposite to this angle PAO, we have side PO. Opposite to QCO, angle QCO, we have the side OQ. Okay, if PAO is less than QCO, we'll be having OP less than OQ. Yes, what is the reason? Side which is opposite to the smaller angle will be smaller, or side opposite to greater angle will be greater. So that is the reason. Sides opposite to smaller angle is smaller. So this is the required proof. Yes. So we have proved that the greater chord is nearer to the center. The distance of greater chord from the center is OP, and we have proved that PO is less than OQ. Okay. Since PO is less than OQ, the greater side is nearer to the center compared to the smaller chord. Okay. Understood this? Next, problem number 2, question 7 of exercise 18C. In the given figure, C and D are points on the semicircle described on AB as diameter. Given angle BAD is equal to 70 degrees and angle DBC is equal to 30 degrees. Calculate angle BDC. Where do we have BDC? BDC. This angle we have to find. Given that angle BAD is this angle which is 70 degree, and DBC, this angle is 30 degree. Okay, here when you consider this figure, this is a semicircle. Semicircle is a part of circle. A, B, C, D are points on the semicircle, which means A, B, C, D forms a cyclic quadrilateral. A, B, C, D is a cyclic quadrilateral. What is given in the question? Given angle BAD is equal to 70 degree and DBC is equal to 30 degree. We need to find angle BDC. Okay, we have to find BDC. What is the peculiarity of a cyclic quadrilateral? For a cyclic quadrilateral, the sum of opposite angles will be equal to 180 degrees. So here BCD and BAD are opposite angles. Okay. Therefore, when the sum taken, you have to get 180 degrees. Angle BCD plus angle BAD is equal to 180 degrees. Now put the value. Angle BCD is equal to 180 degree minus BAD. That is 180 degree minus, what is BAD? BAD is equal to 70 degrees. 180 minus 70 degrees. You get 110 degrees. BCD, this angle is 110 degrees. How we are getting this 110 degrees? Because sum of opposite angles of a cyclic quadrilateral is 180 degrees. Okay. Now, consider this triangle. Consider triangle BCD. In triangle BCD, we know CBD, angle CBD. Then angle BCD is not. We just need to find CDB. How to find CDB? We know that the sum of interior angles of a triangle is always equal to 180 degrees. We have angle DBC plus angle BCD plus angle BDC equal to 180 degree. Sum of interior angles of a triangle is 180 degrees. Okay. Now put the values. DBC. DBC is given, that is 30 degree. Then BCD. BCD we have determined, which is 110 degrees. Plus BDC. BDC we need to find. Keep it as it is. BDC is equal to 180 degree. 110 degrees plus 30 degree, we get 140 degree. Plus BDC is equal to 180 degrees, which means angle BDC is equal to 180 degree minus 140 degree. What is the value? Angle BDC is equal to 40 degrees, correct. Angle BDC, this angle is 40 degrees. Okay. First, we are taking the cyclic quadrilateral. Sum of opposite angles is 180 degree, using which we have determined angle BCD. Then considering this small triangle BDC, sum of interior angles will be equal to 180 degree, and we are finding angle BDC, which is 40 degrees. Clear? Let's move on to the next problem. Problem number 3, question 15 of exercise 18C. In the given figure, ABCD is a cyclic quadrilateral. PQ is tangent to the circle at point C and BD is its diameter. If DCQ is equal to 40 degrees and ABD is equal to 60 degrees, we have to find DBC, BCP and ADB. DCQ. DCQ. This angle is given, which is equal to 40 degrees. Then ABD. ABD is given, which is 60 degrees. DBC. DBC. First we have to find this angle. Then BCP. BCP. This angle. And ADB. ADB. This angle. Okay. First let us find DBC. Angle DBC. How to find DBC? Here we have DBC. It is given that angle DCQ is equal to 40 degree. Is there any relation between this DCQ and DBC? When you consider the chord DC, okay, if you consider the chord DC, tangent PQ and DC makes an angle of 40 degree, okay, at this point of contact. Also, this chord DC in the alternate segment is this major segment. In the alternate segment, subtends an angle CBD, which means these two angles should be equal. Therefore, the angle DBC should be 40 degrees. Understood? Angles in the alternate segments. Angle DBC is equal to angle DCQ, that is 40 degrees. What is the reason? Angles in the alternate segment are equal. Okay, when you consider the chord DC and tangent at the point of contact C makes an angle 40 degrees. Here, the same chord in the alternate segment subtends an angle of 40 degrees. Okay, therefore, angle DBC will be equal to 40 degrees. Now, the next one we have to find BCP. Where do we have BCP? BCP is this angle. How to find BCP? BCP and BDC will be equal. Angle BCP will be equal to angle BDC. Is there any method to find BDC? In this triangle, consider triangle BCD. Here it is given that angle DBC is equal to 40 degree, which we have determined in the first part. Then we will be knowing angle DCB. What is angle DCB? Angle DCB will be equal to 90 degrees. Why? This is an angle which is subtended by the diameter or angle in a semicircle. Angle in semicircle. Okay. Two angles we know. We can find the third angle, right? Angle BCD plus angle BDC plus angle DBC is equal to 180 degree. Sum of interior angles of a triangle is 180 degrees. Now put the values. BCD is 90 degree plus BDC we have to find plus angle BDC plus DBC we have determined, which is 40 degree. Total will be 180 degree. 90 plus 40, 130 degrees plus BDC is equal to 180 degrees, which means BDC will be equal to 180 degree minus 130 degree, which is 50 degrees. Okay, BDC we have determined, that is 50 degree. If BDC is equal to 50 degree, we will be having BCP, angle BCP also equal to 50 degrees. What is the reason? Angles in alternate segments. Okay, here when you consider the chord CB, between CB and the tangent, here we have an angle which is the required angle BCP. Okay, the same chord subtends an angle BDC at this point, that is at point D, which is 50 degree. Therefore, BCP is also equal to 50 degree. Okay, alternate segments, the angles are equal. Next, the third part, we have to find angle ADB. ADB, this angle. Here, we will be having angle DAB equal to 90 degree. What is the reason? DB is the diameter and the diameter subtends 90 degree angle on the circle. Okay, or this is the angle in the semicircle. Angle DAB is equal to 90 degree. Consider triangle DAB. We have angle DAB equal to 90 degree. Then we have DBA is equal to 60 degree, which is given in the question. ABD and DBA are the same angle, that is 60 degree. Then we can find ADB. ADB plus DBA plus DAB is equal to 180 degree. What is the reason? Sum of interior angles of a triangle is 180 degrees. Now put the values. ADB, we have to find ADB plus DBA. DBA is 60 degrees plus DAB. DAB is 90 degree equal to 180 degree, which means ADB plus 60 plus 90 degree, we get 150 degree equal to 180 degree, which implies ADB equal to 180 minus 150. 180 minus 150 is 30 degrees. ADB, this angle is 30 degrees. Okay, so we have determined angles DBC, BCP and ADB. Understood? Next, problem number 4, question 18 of exercise 18C. In the given figure, AC is equal to AE. AC, here we have AC and this is AE. Show that CP is equal to EP. CP is this part and EP is this part. And also BP is equal to DP. Here we have BP and this is DP. Considering this figure, we'll be having. Now, when you take these sides, AC and AE, given they are equal, given AC is equal to AE. If two sides are equal, then the angles opposite to them will also be equal. For that, what I am going to do is, I am going to join the C and E points. Similarly, I will be joining B and D points. Okay. When you take this side AC, opposite to AC, we have angle AEC. Yes, angle AEC. Similarly, when you take AE, opposite to AE, we have angle ACE. Angle ACE. Since AC is equal to AE, angle AEC will be equal to angle ACE. Angles opposite to equal sides are equal. Angles opposite to equal sides are equal. Okay, let us take this as some equation 1. Now, ACP and AEP will be equal. ACP is this angle and AEP is this angle. What is the reason? When you consider the chord BD or the RBD, BD subtends angle BCP and DEP on the circle. Yes, that is angles are subtended in the same segment. Same is the angle ACP. BCP and ACP are the same angles. So, we will be having angle AEP equal to angle ACP. This I am taking as equation 2. What is the reason? Angles in the same segment. In the same segment. Okay. Now, when you take this ACE, total angle ACE, it is made up of ACP and PCE. Okay, that is, in order to get this PCE angle, we need to just subtract this ACP from the total angle ACE. For that, what I am going to do is, I am going to subtract second equation from first equation. Equation 1 minus equation 2. Left hand side, what we have? Here it is AEC minus AEP and RHS ACE minus ACP. AEC minus AEP will be getting PEC. Angle PEC equal to ACE. ACE is this angle and ACP. ACP is this part. We get PCE. Angle PCE. What is the side opposite to PEC? PE PEC, this angle. Opposite to PEC we have CP. Yes, therefore CP will be equal to PCE. When you take this angle PCE, opposite to PCE we have side EP. Okay, therefore sides opposite to equal angles are equal. You will be getting CP is equal to EP. So this is the first part. Okay. Next we have to show that BP is equal to DP. Here we have BP and this is DP. For that, when I consider chord BC, okay, considering chord BC, I'll be having BDC equal to BEC. Yes, angle BDC equal to angle BEC. BEC can also be written as PEC. Yes, angle PEC. What is the reason? Angles in the same segment. Angles in the same segment. Okay. Now, when I take this chord DE, I'll be having angle DBE is equal to angle DBE is equal to angle DCE. DCE can be written as PCE. Yes, angle PCE. Same reason, angles in the same segment. That is the angle subtended by chord DE. Here we already have PEC is equal to PCE. PEC and PCE are equal. That is right hand side is equal, which means left hand side also should be equal. Therefore, BDC will be equal to DBE. BDC. BDC. BDC can be written as BDP. Yes. BDP is equal to DBE. DBE can be written as DBP. They are the same angles. DBP. Okay. If BDP is equal to DBP, then the sides opposite to them should also be equal. Opposite to angle BDP. BDP, we have side BP. Okay. BP is equal to DBP. Opposite to DBP, we have side DP. Okay. DP. Sides opposite to equal angles are equal. Okay. So here we have the proof. We got BP is equal to DP and CP is equal to EP. Okay. So this is the second one. Clear? Understood this? Next, problem number 5, question 32 of exercise 18C. In the following figure, a circle is inscribed in the quadrilateral ABCD. If BC is equal to 38 cm, QB is equal to 27 cm, DC is equal to 25 cm, and that AD is perpendicular to DC, find the radius of the circle. Here we have the circle. You can find ABCD quadrilateral and a circle inscribed within the quadrilateral. Here we have BC. BC is given 38 cm. Then QB. QB is this part. This part is 27 cm. DC. DC is this whole part, which is 25 cm. And then it is given that AD is perpendicular to DC. Okay, this angle is 90 degree. Now when you consider this circle is inscribed in the quadrilateral, which means here we'll be getting angle made between the radius and the tangent. Here AD is a tangent, okay, P is the point where it meets the circle and OP is the radius. Okay, the angle made between OP and the tangent will be equal to 90 degree. So this angle is 90 degree. Similarly, here again we have a radius of circle and this is a tangent. Angle made between the tangent and the radius will be equal to 90 degree. This angle is also 90 degree. Okay. When you consider this part, here we have 3 angles equal to 90 degree. For a quadrilateral, we know that the total angle will be equal to 360 degree. If 3 angles is 90, 90 plus 90 plus 90, we get 270 degree. Then this angle should also be equal to 90 degrees. Yes. Therefore, We'll be getting this figure to be a square. OPDS is a square. Okay. Why? Because all the angles we are getting 90 degree. Then adjacent sides are equal. Here adjacent sides OS and OP are the radius of circle. Now let us take the radius as some x. Okay. This is x. This is x. Then since this is a square, we will be having all sides x. Okay. Now we have DC. The total length DC is equal to 25 centimeter. Also DS is equal to x. We have taken DS as x. Then what is this SC? SC will be equal to DC minus DS. The total DC minus this part DS. Put the values. We will be having 25 minus x. 25 minus x centimeter is the length of SC. Is there any relation between SC and RC? I am saying that SC will be equal to RC. What is the reason? Here from this point C, SC and RC are tangents which are drawn to the same circle. Therefore, when you have an exterior point and tangents are drawn to the same circle, you will be having the length of tangents equal. Therefore, we will be having SC equal to RC. Tangents drawn from an exterior point to the circle will be of equal length. Okay, length of tangent will be equal. Therefore, SC is equal to RC. SC is equal to RC. Then what is RC? RC will be equal to 25 minus x centimeter. Okay, this part RC is 25 minus x. Okay, now how to find RB from this? RB will be equal to BC minus RC. BC is this whole part and RC is the small portion. Okay, put the values. What is BC? BC is given, which is 38 centimeter. 38 minus RC. RC is the small portion, which is 25 minus x. 25 minus x. That is 38 minus 25 minus of minus plus x. 38 minus 25 will be getting 13 plus x. 13 plus x is RB. RB. This portion is 13 plus x. Okay. Is there any relation between this RB and QB? RB. I am writing RB equal to QB. Again, same reason. That is, when you consider an exterior point B, QB and RB are tangents which are drawn to the same circle. Tangents drawn from an exterior point to the circle is of equal length. Is of equal length. Okay, therefore we will be having RB is equal to QB. QB we know, which is 27 centimeter. Okay, RB 13 plus x is equal to 27, which means x is equal to 27 minus 13, and that is 14 centimeter. What is x? X is the required radius of the circle. Radius of circle. Radius of circle is equal to 14 centimeter. The only concept that we are using here is from an exterior point, when tangents are drawn, they will be of equal lengths. Okay. Clear? Next, problem number 6, question 34 of exercise 18C. In the given figure, QAP is the tangent at point A and PBD is a straight line. If ACB is 36 degrees and APB is given, which is 42 degrees, find BAP. First we have to find BAP. How to find BAP? to find angle BAP. What is the relation between BAP and BCA? I'll be writing angle BAP equal to angle BCA. What is the reason? Here when you consider this chord BA chord makes an angle of 36 degree with the tangent. Why? Because here the same chord subtends angle BCA on the circle. Okay. Therefore, the angle subtended by the chord on the circle will be equal to the angle that is between the tangent and the chord. Okay. Therefore, this should be equal to 36 degrees. Angle BAP is equal to BCA. That will be equal to 36 degrees. That is angles in the alternate segment. Okay, alternate segment. Here BCA is an angle that is subtended by the chord BA on the major segment. Now we got BAP, angle BAP is 36 degrees. Now the second one we have to find angle ABD. How to find ABD? Where do we have ABD? ABD. This angle. How to find ABD? When you take this triangle PBA, ABD is an exterior angle. Exterior angle is the sum of opposite interior angles. Therefore, we will be having angle ABD equal to angle BPA plus angle BAP. Put the values. What is the reason? Exterior angle of a triangle is equal to sum of interior opposite angles. Angle ABD is equal to BPA. BPA is 42 degrees and BAP is 36 degrees. 42 plus 36 will be getting 78 degree. Okay. Therefore, this angle is 78 degree. Now the third one, we have to find angle QAD. Where do we have QAD? QAD. This angle. How to find QAD? QAD is an angle that the chord DA and tangent makes. Okay. Same chord in the alternate segment subtends an angle DBA. Yes. Therefore, angle DBA should be equal to angle QAD. DBA is the angle that we have determined, which is ABD. ABD is 78 degrees. Therefore, QAD will also be equal to 78 degrees. Angles in alternate segments. Okay. This angle is subtended by the chord and the tangent. Here, the same chord subtends angle 78 degree on the circle. Therefore, QAD is also equal to 78 degrees. Now, the fourth one, we have to find BCD. BCD. This whole angle. Here, ABCD. ABCD is a cyclic quadrilateral, right? ABCD is a cyclic quadrilateral. We know for a cyclic quadrilateral, the sum of opposite angles will be equal to 180 degree. That is, angle BCD plus angle BAD will be equal to 180 degree. If we are able to find BAD, we can find the value of BCD. So, here we have PAQ is the tangent and it is a straight line. So, we have the total angle on a straight line should be equal to 180 degree. Angle PAB plus angle BAD plus angle DAQ will be equal to 180 degree. Sum of angles on a straight line. straight line is 180 degrees. Now put the values. PAB. PAB is 36 degree plus BAD. BAD we have to find angle BAD plus DAQ. DAQ or QAD that we have determined, which is 78 degrees. 78 degrees is equal to 180 degree. Okay. Now 36 plus 78 will be getting 114 degree plus angle BAD. BAD is equal to 180 degree and angle BAD will be equal to 180 degree minus 114 degree. What is 180 minus 114 degree? We'll be getting 66 degrees. Okay. So this angle is 66 degrees. Then what about BCD? Angle BCD. Angle BCD will be equal to BCD plus BAD equal to 180 degree. Then BCD will be 180 degree minus BAD. BAD we have determined, which is 66 degrees, and that will be equal to 114 degree. So required angle BCD. BCD, this whole angle is equal to 114 degrees. Okay. Understood? We have determined all the 4 angles that is required. Next, problem number 7, question 40 of exercise 18C. In the figure given below, O is the center of the circumference of triangle XYZ. XYZ. Tangents at X and Y intersect at point T. This is first tangent XT and this is YT is the second tangent. They intersect at point T. Given angle XTY. XTY is 80 degrees and XOZ. XOZ is given, which is 140 degrees. Calculate the value of ZXY. ZXY. Okay, we have to find this angle ZXY. How to find ZXY? Here, when you consider this triangle, consider triangle XTY. Okay, in triangle XTY, XT will be equal to YT. What is the reason? XT is equal to YT. Tangents drawn from an exterior point to the circle are of equal length. Okay. The tangents which are drawn from an exterior point. Here T is an exterior point. Tx and Ty are tangents which are drawn from this exterior point to the circle. They will be of equal length. We got xt is equal to yt. If xt is equal to yt, then the angles opposite to equal sides will be equal. Opposite to xt, we have the angle xyt. Angle xyt equal to, opposite to yt, we have yxt. yxt. Okay. If I am taking xyt as some x, then yxt will also be equal to x. So here, considering the triangle xty, will be having x plus 80 degree is equal to 180 degree. Sum of interior angles of a triangle is 180 degrees. Okay, x plus 80 degree. X is angle yxt plus xyt plus xty is equal to 180 degrees. 2x plus 80 is equal to 180 degree, which implies 2x is equal to 180 degree minus 80 degree. Then what is the value of x? 180 minus 80 will be getting 100. X will be equal to 100 divided by 2. X is equal to 100 by 2 and that is 50 degrees. Okay. We are getting this angle as 50 degree and this also will be equal to 50 degrees. Now similarly, when you consider another triangle, consider triangle XZO. Okay, XZO. Here I have XO equal to ZO. What is the reason? O is the center of circle, then XO and ZO are the radius of the circle. That is radii of circle. Radii of circle will be of equal length. Okay, then angles opposite to them should also be equal. Angle OXZ will be equal to angle OZX. This angle and this angle will be equal. How to find the measure of these angles? Here in this triangle, if I am taking this angle as y, then this angle will also be y. Therefore, y plus 140 degree is equal to 180 degree. Same reason, that is sum of interior angles of a triangle is 180 degrees. Okay, 2y plus 140 degree equal to 180 degree. Then 2y is equal to 180 degree minus 140 degree. What is the value of y? 180 minus 140 will be getting 40. 2y is equal to 40, which means y is equal to 40 divided by 2, and that is 20 degrees. Okay, we are getting this angle 20 degree and this angle 20 degree. Now we have to find ZXY, right? To find ZXY, we need two angles, that is ZXO and OXY. ZXY will be angle ZXO plus angle OXY. ZXO we have determined, which is 20 degree. Now how to find OXY? To find OXY, here OX is the radius of circle and XT is the tangent. What is the angle between the radius and tangent? Angle between radius and tangent will be equal to 90 degrees. Okay. Angle OXT is equal to 90 degrees. That is angle between radius and tangent. Here this angle OXT is equal to OXY, this part, plus TXY. Okay, OXY plus TXY we already had determined, which is 50 degree. OXT is 90 degree. 90 degree is equal to angle OXY plus TXY. TXY is equal to 50 degrees. Therefore, OXY will be 90 degree minus 50 degree, and that is equal to 40 degree. So, we got OXY. This part, it is 40 degree. Then what is the total angle? ZXY. ZXY is equal to ZXO plus angle OXY, that is 20 degree plus 40 degree, and that is equal to 60 degree. The required angle ZXY is equal to 60 degrees. Clear? Okay, let's move on to the next problem. Problem number 8, question 42 of exercise 18C. In the given circle with center O, angle ABC is equal to 100 degree, angle ACD is equal to 40 degrees, and CT is a tangent to the circle. We have to find angle ADC and DCT. ADC. First we'll find this angle, angle ADC. How to find ADC? Here we have a circle. ABCD is the cyclic quadrilateral, right? ABCD is a cyclic quadrilateral. We know for a cyclic quadrilateral, the sum of opposite angles will be equal to 180 degrees. Angle ABC plus angle ADC will be equal to 180 degrees. Sum of opposite angles of a cyclic quadrilateral is 180 degrees. Okay, here we have ABC given. ABC is given in the question, which is 100 degrees. 100 degree plus angle ADC equal to 180 degree. Therefore, ADC will be equal to 180 degree minus 100 degree, and that is equal to 80 degree. We got ADC. ADC is 80 degrees. Okay. Now, we have to find DCT. Where do we have DCT? DCT. DCT is the angle between chord and the tangent. We have angle DCT equal to angle CAD. I can write angle DCT equal to angle CAD. What is the reason? Angles in alternate segment. Alternate segment. Here, the chord DC and the tangent makes an angle DCT. The same chord in the alternate segment, that is the major segment, makes an angle CAD on the circumference of circle. Therefore, they will be equal. This angle and this angle should be equal. If we are able to find CAD, then we will be getting the value of DCT. How to find CAD now? Consider the triangle. Consider triangle CAD. Okay, two angles we know, then we can find the third angle. Angle CAD plus angle ADC plus angle ACD will be equal to 180 degree. Put the values. CAD we have to find angle CAD plus ADC. ADC is 80 degrees and ACD is 40 degrees. Plus 40 degrees is equal to 180 degree. Then CAD plus 80 plus 40, 120 degree is equal to 180 degree. That is CAD equal to 180 degree minus 120 degree, and that is equal to 60 degree. CAD, this angle is 60 degree. We have CAD equal to DCT. That is, angle DCT is also equal to 60 degree. The required angle DCT is equal to 60 degrees. Okay, that's all for today. In today's class, we have solved plenty of questions from exercise 18C. There are a few more questions which you can practice on your own. I'll be back with a new chapter in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.